Good evening, good afternoon. My name is Zachary Zhang. I am currently a 10th grader at Harvard Westlake School. And before I want to start this presentation, I want to give a big thank you to my instructor, Mr. Ansha, who was unfortunately unable to attend this presentation for today. So I give a huge big thank you to him for helping me out with everything here. So without further ado, I present to you a mobile app for tracking psychological mood changes and providing e-therapy using natural language processing and GPT-3. So here is what we'll be going over for this presentation today. We'll talk about sort of what problem I wanted to address or we wanted to address. We'll talk about the app itself, namely its features and also its functions. And we'll also talk about what challenges we encountered while developing the app. We'll also talk about some experience we did and their results. And finally, to top it off, we'll talk about some concluding remarks. So the problem at hand is obviously mental health. So in 2022, 5% of individuals age 18 and over report regularly having feelings of depression, and 12.5% of said group, they report regularly having feelings of worry, nervousness, or anxiety. Obviously, this was a major driving factor for us to create this app and conduct any sort of research based on it, because it kind of shows that mental health is on the rise. And normally, to sort of, I would say, seek help. If you want to seek help for any sort of mental health related issues, you will go to a therapist. And this is actually really useful. But however, we found that therapists also have their flaws. For example, some therapists are prone to bias, which is obviously negative, as it leads them to make assumptions and judgments about their patient, which they shouldn't be having. And this leads to inaccurate diagnosis, which is not helpful at all. And some therapists may not be as professionally trained, and this can lead to misdiagnosing or dismissing the root cause of concern in their patients. So in summary, the problem is that people are having trouble finding the exact cause of their mental health problems. And if you're wondering, no, this is not, we're not sort of making this app to replace every living, breathing therapist in the world with an AI one. Our actual goal for this app was to create a program which could aid in the process of determining a root cause to an individual's mental health problems. So we wanted to create this app to sort of work in conjunction with therapists or any other sort of professional treatment to sort of locate that root problem and sort of find ways to see if we can alleviate it. So this is our app. And to aid in the person's path of mental health recovery, we propose an app which can track the user's mood and record any mood changes, whilst also providing e-therapy using GPT-3, also known as Generative Pre-trained Transformer 3, and its natural language processing capabilities. Before I go on, we also named this app Insightful. That's our app name, and that's our logo right there. So the app features daily mood check-ins, which can monitor the user's mood over a span of several days or months. And GPT-3 is used to form the basis for an AI chatbot in the app, which can provide recommendations based on how the user is feeling today and their overall mood. Users can also have the option to create journal entries, which are similar to diaries, and these entries have a sentiment score tied to them. We'll go over what the sentiment score is in a later slide. So everything in the app, all of its features, the chat, journaling, and recommendation page, they all work together to provide sentiment context for GPT, for the AI. And all of the information, so essentially everything and the data, they're stored within Firebase, which is a service hosted by Google that has the capability to sync and store data in real time. So we'll be using that Firebase as sort of our primary data bank and data storage for this app. So most data types in this app, they contain a variable called sentiment score, which is updated when it's created within another variable, such as an entry or a message. And this score makes sure that GPT-3 has context and will also respond correspondingly and appropriately to the user. So the sentiment score, essentially what it is it's a value ranging from 0 to 1 that sort of represents the connotation for something. So for example, a sentiment score could sort of represent how positive or negative a journal entry is. We'll go into sort of the details of that later. And we used Dart, the coding language, to build this app, and the tech stacks, basically technologies used to build this app, everything, include Flutter, Firebase, and the OpenAI GPT API. Here is sort of an overview of our app. We'll go over like everything here in a second. This sort of chart or graph, it actually helped us visualize sort of how everything in the app interacts and connects with each other. And we'll go over sort of the journal screen, the chat screen, the device screen. So everything here we'll go over next. So first off, let's talk about the chat screen and the chat system. In the app, the user has the ability to chat with a chatbot, and this chatbot will respond accordingly to the user based on what they say and their sentiment score. And this is actually where the sentiment score comes into play here, because normally when you talk to a chatbot, ChatGPT, or anything sort of that matter, the only thing it really takes in is what you type to the chatbot, and if it has the capability to, it can also sort of backtrack your conversation and pull things that was said before. But however, we found that chatbots, they have a problem. They can't really solidly determine a person's mood just based on the person's input. So, for example, if I were to say a chatbot, I'm so happy today, but you're actually not feeling happy. You're actually really sad, and you're saying I'm feeling happy to mask that sort of feeling of sadness. The chatbot doesn't have a solid way of knowing if you're actually happy or not. It's just gonna, from what's being said, it's going to assume that you're in a good mood, which is in this case not true. So this is where the sentiment score comes in. The chatbot knows the user sentiment score, so it always has context, regardless of what's being inputted. So let's go into how this chatbot works. First, the user sends a message, which is then sent to Firebase and added to the main conversation record. And the last 4 messages of the chat are compiled and fed as data to the GPT class. This exists to provide the chatbot with context, so it will not forget everything that's being said. The chat then waits for a response from Firebase and updates in real time and automatically when the chatbot receives any new data from the GPT API. So this is sort of an in-depth view on how everything works. So we have a function titled send request, and this creates an OpenAI class instance. And so the GPT API key, which is really important, is fetched from Firebase. so this key isn't stored locally, which prevents other people from using it. And it's also added to the OpenAI instance. And next, a GPT request is then constructed using the message context function to give the API some preliminary conversation history. So for example, to provide some context on what's been going on with the recent messages. The function then awaits the API response. And then we have another function called construct messages from message class. This takes one parameter, which is a list of message. And message is a custom data type used to store information about a message, such as whether the bot sent the message or the user sent the message and when was the message sent. So everything here is converted into a GPT message and categorized into a user or assistant role. And that's how it works. Second, I want to talk about the journaling page. So in the app, users can create diary-like journal entries. Journaling actually helps a lot with sort of mental health, as it provides you with an outlet to sort of type or write about your feelings. So journaling is actually a key component if we're going to address anything related to mental health. So speaking of that, all of the journals in this app can be accessed in the journal page. And we also have basic cards to represent each entry. I'll show you guys that later. The page features UI to view and edit the contents of an entry. So once you're done with a journal, it's actually not final. You can always go back in there, change things up, add new things that you weren't able to add before. So nothing is final when it comes to journaling in this app. And the data for the journal is saved in real time to Firebase when edited. So it's always sort of constantly being updated. And of course, we calculate a sentiment score based on what was in the journal. It works sort of by seeing what words have either positive or negative connotations and averaging that up. So I wanted to talk about sort of the journal entry feature. The code in figure 1, everything here, this basically builds a filter card for the journal. And then the user is taken to the journal form once they press the plus button on the journaling page view. And in this form, the user can then proceed to type their journal's contents, such as the title and sort of what they want to talk about. And once the user is writing, a function takes in what was typed. Oh, that was not supposed to happen. Speaking of which, the journal class in figure 1 contains some internal functions to convert the data types into types appropriate for storage in Firebase, because Firebase doesn't really accept some data types. So this includes the JSON format, which is a map of strings to dynamic data types. And of course, we also have a function which contains optional parameters to define whether the query should be sorted by date or not. And that's the journaling app. There we go. Okay. So third feature is the mood check-in. This is sort of a daily check-in feature, which helps to monitor the user's mood. The mood check-in has 2 screens, one for the user to input how they're feeling today, and another to sort of input what made the user feel this way or the possible cause of the mood. And when the user is done, they can click on the complete check-in button, and this completes the mood check-in for the day and sends the data to GPT. So for the mood check-in, the data for all previous check-ins are displayed on the in-app calendar. So the user has the ability to see sort of how their mood changes over time. The calendar only records the days which you actually completed the check-in. So as you can see from the sample image, there's a lot of sort of blank days. So this is just sort of a demo on what it will look like. Let's see. So this calendar mainly exists to give the user the authority to monitor their mental health fluctuations throughout the week and figure out, and it also helps with figuring out the root cause of their emotional distress. So on the recommendation page, the chatbot or GPT-3, it will be able to provide appropriate responses that are displayed on cards, which take in consideration for the user's mood and the average general sentiment score.
I think some network issue for Zhang. We'll just wait for 5 minutes.
Everyone, my internet had a connecting issue, so that's why
Yep, Zhang. So you can continue now. It's fine.
Oh, sure, thanks. All right, so as I left off, the mood check-in, which is this is like the second part of talking about the mood check-in. So this mood class, which is sort of a list of mood and responses created, it actually stores the mood, the reason for the mood, and also the check-in date for the mood check-in. And the function on the bottom here, which is save state to Firestore, this function removes the time from the date and leaves only the day, month, and year values to make daily check-in querying easier. I'll go into this detail later. Before this, we actually sort of recorded literally everything about a mood check-in, and that actually led to some errors. So we made it simpler by not deciding to not include as a lot of values when we're going to save the mood to Firestore or Firebase. And then the function converts the mood object to a JSON object, which is sort of something that Firebase accepts, and it uploads that data to Firebase Firestore. And a grid view of the moods with their rendered emojis is created, as well as a page for the mood reasons grid. That's the mood check-in. So here is an overview of sort of all of the systems. As you can see, we have the chat, journaling stage, and also sort of activity recommendation and mood check-in. So this graph helped us with sort of, again, visualizing a lot of the features, how each piece of code sort of intertwines and connects with each other. So as you can see, for example, like the journaling stage, after the journal entry is saved, we compute the sentiment score or the average sentiment score. And then this sentiment score then goes into the chat feature, which after the user sends the message, after it goes to Firebase, the GPT request then takes in the conversation context from like the journaling stage and uses that to sort of make a response and update the chat. Same here for activity recommendation and mood check-in. So the mood input, it actually sort of changes the average sentiment score. It edits the average sentiment score depending on what you put for the check-in. And this also relates to sort of how GPT-3 will give activities, as GPT-3 will sort of compute the average sentiment score before giving an activity to determine what is an appropriate response. So the mood input actually has a lot to say in recommending activities. So that's my system map. There were a couple challenges encountered during development. So we'll be going over this. So first challenge is fetching valid mood check-in data from the database. We also encountered a challenge, not really a challenge, it was more sort of, we didn't know what type of calendar we wanted. And we also had an issue where chat messages aren't loading from the last entry in the UI. So our first challenge we encountered was that we weren't able to fetch valid data. So essentially, I think we talked about this before. The mood check-in has a timestamp field called checked in, which stores information about both the date and time of the check-in. And so when the user checks in and opens the app 1 day later, the mood check-in for all the previous day is still shown. So it doesn't really sort of has trouble actually sort of updating. And how we fixed this was we completely removed the time aspect from the data type. So we only use the current day's date information. And this makes it a lot easier to filter the database for entries created adjacent to each other in time. So it makes it easier, so it makes the data easier to digest in a way. And here you can see an image of the mood class that is taken after we fixed the problem. So everything here looks a bit cleaner than it used to look before. Another challenge we encountered, actually not a challenge, it's more of like indecisiveness. We were split on whether if we should use a custom built calendar or implement a third-party library. Both of these options are actually really reasonable choices for us, and that's why we weren't able to decide on one of them. But we eventually went with the library/package option because it was just more convenient and less time consuming to implement. And finally, we have a problem where the chat messages do not load from the last entry. So essentially what was going on was that chat messages, they were being loaded/fetched in full. So everything from the chat messages were being fetched from Firebase. This affects the user experience as well as consuming a lot of bandwidth and data, which is not ideal to say the least. And the list view also used to view the messages, did not actually want to scroll to the bottom of all of the messages when it's loaded. And we fixed this by loading the messages in batches to sort of ease the strain on the bandwidth and the data being transferred. And regarding the issue of the list view not scrolling down to the bottom, the way we also fixed the way the message list was being generated. So on this side, on the right side, you can see this is sort of the statement and the Boolean that control the retrieval of the messages. And basically what it does is it queries for the messages in batches of 15. And the Boolean has more data, it's automatically set to true. And if it's set to false, and once fewer than 15 messages are received, which is below the limit, and if the number of messages is less than 15, no more messages will be fetched, as by that point, it's kind of assumed that there are no more messages being loaded. So that's the function to handle that. And we also conducted some experiments with the features in our app. So our first experiment came from the problem that GPT wasn't really giving us unique responses or recommendations when it came to the mood page. So our first experiment was changing the prompt to encourage GPT to provide unique outputs. And our second experiment, we wanted to assess how well GPT can respond accordingly to the context, and that's based on sentiment score. So our second experiment was rating sentiment scores to assess how well the output matches the context. So for our first experiment, we wanted to generate more unique recommendations with GPT. So essentially what we did here was we used a random seed in the prompt to quote unquote trick GPT to encourage it into having different input statements. And the goal was to generate as many unique activity recommendations as possible, while also using the average sentiment score and the randomization seed. So here are our findings for the first experiment. We found that the mean and median for results was one unique recommendation. The highest number of unique recommendations recorded was 3. It was actually 3 out of 3 recommendation cards. And this was obtained in a continuous sequence of prompting the GPT 5 times in a row. It's also important to note that this only happened once. So, and in conclusion, we found that the number of recommendation cards generated has the largest effect on the number of unique recommendations generated by the AI. So that's what we sort of found through all of our findings for the first experiment. And our second experiment stemmed from our concern that the AI wasn't able to understand how sentiment scores can be rated from good to bad. And we were kind of afraid if the AI would not listen to the sentiment scores. So we wanted to assess the ability, the AI's ability of relating sentiment score to its response. So the sentiment score is actually calculated by either taking an average of all journal entry scores or summing or adding all of their respective scores to obtain a balance, which is used by GPT to make decisions. And to calculate the sentiment values, we used a library called Dart Sentiment. And this library is based on the akin, AFINN 165 dataset. Essentially what that is it's a huge list of a lot of different words. And each of these words, they have a value, a numerical value assigned to them, depending on their sort of, if they have like a positive or a negative connotation. So that's how we determine our sentiment score. So our goal for this experiment was to see if the sentiment score affected the relevancy of the responses being generated by the AI. So here are our findings for the second experiment. So if you see these red dots here, just imagine there's a line going through them, and that line formed by the red dots, which is not visible, it represents one of three indication values, low, medium, or high. So we then use these values to rate the relevance of GPT's output to the average sentiment score. So they were sort of rated on a scale from 0 to 1. This is similar to how you will rate something from 1 to 10 or anything of that matter. So 0 in this context means low, 0.5 means medium, and 1 means a really high sentiment score. So the relation of everything here refers to sort of how appropriate a response was according to the sentiment value. So for example, negative sentiment values usually indicate negative life occurrences. And also the data point, for example, data point with the high sentiment score was for us in our experiment, an extremely positive journal entry that we made. So all data points, everything here, they appeared an equal number of times. We found that the average sentiment score was 2.85. The average relational score was 0.25. And this kind of shows how the non-uniqueness of the data is sort of returning again. So in conclusion, from this experiment, we concluded that the GPT pipeline, it does show some understanding of its context, but the data generated is not consistent enough to align itself with that context, regardless of the sentiment score. So we actually thought of a proposed solution to this. We could, 1, switch the model being used, or 2, generate the recommendations at a slower pace. So that's the solution to that. And conclusions, I believe that our app was a success, was successful. It helped to fulfill the role of a self-help therapist as well as a mental health tracker. But however, I feel like there is a lot of improvements that could have been made to the app to improve user experience. So for example, the app lacks a statistics page to view information. So like all of the mood check-ins, the number of journal entries, so everything there to sort of give the user comprehensive summary of their activities in this app. And we were also missing a sorting feature, which could help arrange journal entries. And we also found that the journal entry page's UI was really rough around the edges, and improvements could be made to that to help better user experience. The app was also missing the ability to add videos or images to journal entries. And again, we also wanted to improve the UI by sort of making it more polished, but we didn't really have a lot of time for that. We also could have added larger buttons and animations to provide an overall more interactive and sort of more better user experience to make it more interesting. We also could have enhanced the prompts used to generate advice and recommendations. We could have made this prompt a bit more specific, more detailed, but for now, we just have to stick with a regular, not extremely detailed prompt. And the app was also missing the ability to save multiple AI chats. So for example, if you ever talked with ChatGPT before, you have the ability to sort of save a lot of different chats with the AI bot. We weren't able to implement something like that. And we feel like the app would benefit a lot from not just the last improvement proposed, but everything, all of the improvements here. So we believe that though the app definitely has a lot of limitations and leaves much to be desired, in other words, it could have been better, but we feel like the app still accomplishes its overall goal of being able to provide its users with a psychological outlet, as well as mood tracking over time, and a journal that takes their mood into account. And thank you guys